We're going to look at today some discrete random variables. Now, a random variable uses numbers to describe possible outcomes which could result from a random experiment. It could be represented by a letter X. It could be represented by any capital letter we generally use. What tends to confuse students in the notation for random variables is the fact the random variable is denoted by a capital letter, but particular values will be denoted by a small letter of the same value. We'll come on to that in due course. But the key thing you need to know for this course is what a discrete random variable is. Now, a discrete random variable means it can have distinct values, such as, in this case, we've got wickets a bowler takes or number of defective light bulbs, as opposed to a continuous random variable, which is something you can measure. So this, the length of a race in 100 meters, so 10.6 seconds. You can plot it anywhere on a number line. So if I was to just draw a little sketch of a number line, okay, and we had 10 seconds, 11 seconds, and somebody ran the race in something between that, we could plot them on that number line. No matter how accurate we want to go, we can actually zoom in and get a more accurate value. Whereas with discrete values, there's nothing in between the discrete values. So there's nothing in between 2 wickets and 3 wickets. You can't have 2.5 wickets, but you can have something between 10 and 10.5. Or if you had 10.4 as a time, you can have something between 10.4 and 10.5. It will keep on zooming in. So any measurement is a continuous variable. So time, distance, weight, all these things are continuous random variables. Anything you count is a discrete random variable. Now, there is a sizing measure which isn't a continuous random variable. In fact, most sizing measures for clothing are discrete random variables. So if you have a small, medium, large, extra large, those are discrete random variables. Or if you have shoe size of 8, 9, 10, 11, again, discrete random variables. So there's nothing in between those shoe sizes. So moving on, let's look at some examples. So let's look at these examples. We're going to classify each random variable as a continuous or discrete. So you could look through these in your mind and see if you agree with what I'm going to say in the next few seconds. So quickly give you a few seconds to go through them. You should literally be able to do them in 8 seconds. So if we look at part A, so the quantity of fat in a sausage, well, you'd weigh that using weight, which is a measure, so therefore it's a continuous random variable. And mark out of 50 in a geography test, well, you tend to go up in discrete values, 1, 2, 3, 4, 5, up to the way to 50, or 0 if you're really unlucky, and you get a discrete random variable. The weight of a year student, weight is a measurement, it's continuous. Volume of water in a cup of coffee, volume is again another thing you measure, so therefore it's a continuous random variable. The number of trout in a lake, you're counting, discrete random variable. Number of hairs on a cat, counting, although a very large number, still discrete. The length of a horse's mane, you measure that, so it's a continuous random variable. Height of a skyscraper, again, is another measurement. So moving on, let's look at each of these scenarios, and we're going to identify the random variable being considered, state whether it's continuous or discrete, and give the possible values for the random variable. So to measure rainfall in a 24-hour period, water is collected in a rain gauge. So basically you'll have a funnel and you'll collect it in a rain gauge, and then you're measuring the depth of the rain gauge. Because we are measuring, then it's a continuous random variable. So our random variable being considered is the depth of water in the rain gauge. It is a continuous random variable. Possible values, we generally tend to measure in centimeters or inches, depending on the country you're in. And you may, 2 centimeters rainfall or 1 inch of rainfall would be a reasonable amount of rainfall in a day. Now, moving on. To investigate the stopping distance of Tyre with a new tread pattern, a braking experiment is carried out. Stopping distance, again, is another measurement. So therefore, it's a continuous random variable. The random variable being considered will be the distance it takes to stop at a certain speed. Give possible values for random variables. We'll be working in meters here. So something like 30 meters to 60 meters. Or if you're going very fast, maybe a couple of 100 meters to stop. Or if in icy conditions. To check the reliability of a light switch is repeatedly turned off and on to fail. So we are counting now. So if we're counting, we have a discrete random variable. The random variable would be considered would be the number of times we either turn it on and off before it fails. So that will be the random variable being considered. Types of values, we're probably looking for tens or hundreds of thousands of switch turns on and off before it fails. We certainly wouldn't want it less than that. Last thing to consider before I set you some questions. We're going to suppose the spinners are spun. X is the sum of the numbers. So we're going to sum the numbers on this spinner and this spinner. So the lowest sum could be 2 and the highest sum could be 10. And we can take any value in between those for our sum. So clearly we only have these 9 discrete values. So it's a discrete random variable because it can only take on these 9 values and no value in between. And I have now stated the possible values of x. These are all the different values that x can take on. Right, hopefully you've got an idea what a discrete random variable is now. Here are 3 more questions. So there's question 4, question 5. You can pause the video and go through them. And question 6 you can have a go at.